Hi everyone, welcome to the last chapter of chemistry, which is periodic classification of elements. This is the chapter which is dealing with the history of the periodic table, how the various advancements in science led to the formulation of the latest periodic table which we're seeing right now. And also we'll be discussing certain periodic properties of elements according to the latest periodic table. So let's get started with this chapter, periodic classification of elements. Again, a small chapter which deals with just two topics. First topic, we are discussing about the basis of classification, and second, we are discussing about some important properties, the periodic properties of elements. So let's get started with the first topic, that is the different laws and different theories which led to the modern periodic table. The first proposal was proposed by Dobereiner. Now, Dobereiner suggested a law which is known as Dobereiner's law of triads. Now, he suggested that in certain triads, which is a group of three elements, the atomic mass of the central element was the arithmetic mean of the atomic mass of the other two elements. That means if we have three elements, let us take A, B, and C, which is forming a triad, then the atomic mass of B is equal to atomic mass of A plus atomic mass of C divided by 2. That is the arithmetic mean of the atomic masses of A and C. That is what he have suggested, and he have given some examples for these Dobereiner triads as well. One most common example is that of lithium, sodium, and potassium. Lithium is having an atomic mass of 7, sodium is having an atomic mass of 23, and potassium is having an atomic mass of 39. He suggested that the middle element, that is sodium, is having a mass 23, and this 23 is equal to the arithmetic mean of the first and the third element. The first element was lithium, which was having 7, and the other one is 39. 7 plus 39, that is 46, divided by 2, that comes out to be 23. However, he could identify only few such triads so that the law could not gain much importance. In the triad iron, cobalt, and nickel, all the three elements have nearly equal atomic mass, and hence this particular law was disproved. Then came the next law, which is known as the Newland's law of octaves. Now, what is Newland's law of octaves? According to this law, that is the Newland's law of octaves, the elements are arranged in such a way that the eighth element starting from a given one has properties which are a repetition of the first if arranged in the increasing atomic weight, like the eighth note of a musical scale. So we know that the musical scale consisting of 8 notes: sa, re, ga, ma, pa, tha, ni, and sa. So the first one is also a sa, and the last one is also a sa. That means the first and the eighth notes are repeating. Similarly, the properties of the first and the eighth element according to the Newland's law of octaves are same. That means the periodic properties, the physical properties of those elements are almost similar. That is the meaning of Newland's law of octaves. However, this law was applicable only for lighter elements such as hydrogen, fluorine, chlorine, etc., and it failed in the case of heavier elements. So that was the first drawback which is associated with Newland's law of octaves. Second one is that according to Newland, only 56 elements exist in nature, and that is not correct. We have at present 118 elements, so that was also disproved. No space was left for the elements which were unknown at that time. So he suggested that only 56 elements were there and no more elements will be discovered in future. So that was again a mistake. In order to fit new elements into his table, Newland adjusts two elements in the same column but put some unlike elements in the same column. So that was another drawback. He could not place elements with the same properties in the same column when new elements were discovered. Rather, he put unlike elements in the same column so as to adjust his table. But seeing all these factors, this particular theory, that is Newland's law of octaves, was again disproved. And then came the next theory, that is the Mendeleev's periodic table. According to Mendeleev, the properties of elements are a periodic function of their atomic masses. This is known as Mendeleev's periodic law. Mendeleev's periodic law states that the properties of elements are due to their masses, due to their atomic masses. Now, what are the merits of this particular table, that is Mendeleev's periodic table? First one is that he gave some gaps for the new elements which were discovered later, like the gallium and germanium was not known at his time, but he have given space for those elements in his periodic table without disturbing the existing order. So that was the biggest merit associated with the Mendeleev's periodic table. And talking about the characteristics of the periodic table, in the periodic table the elements were arranged in vertical rows as well as columns were there. Horizontal rows were there and vertical rows were there. The vertical rows were called as the groups and the horizontal rows were called as the periods. So in the modern periodic table also the same pattern is happening. Whichever is coming down, that is known as the period, and whichever columns is going to this side, that is known as the group. So the same concept here also. There are 8 groups according to Mendeleev. There are 8 different groups that is named as 1, 2, 3, 4, 5, 6, 7 and 8. The elements which are belonging to the first 7 groups have been divided into subgroups which are designated as A and B on the basis of similarities. Group 8 consists of 9 elements which were arranged in 3 triads. So these were the characteristics of the groups. So how many groups were there? 8 groups were there, which were named as 1, 2, 3, 4, 5, 6, 7 and 8. The first 7 had subgroups A and B, and the group 8 consisted of 3 different triads which consisted of 9 elements. Then came the 6 periods, which were numbered as 1, 2, 3, 4, 5 and 6, that is the horizontal rows, and in order to accommodate more elements, the periods 4, 5 and 6 were divided into 2 halves, that is A and B. So this was the structure of the Mendeleev's periodic table, where he have given periods as well as groups. Number of periods was 6, designated as 1, 2, 3, 4, 5 and 6, and 4, 5 and 6 were divided into 2 halves, and there were 8 groups. The first 7 were divided into A and B, and the last one consisted of 3 triads consisting of 9 elements. Now, what were the achievements of Mendeleev's periodic table? The first achievement was that the arrangement of elements was very systematic. Second one, many gaps were left in the table for undiscovered elements. However, properties of these elements could be predicted from advance from their expected position. So that was the biggest merit of Mendeleev's periodic table. Another one is Mendeleev corrected the atomic mass of certain elements with the help of expected positions and properties. These were the 3 different achievements of the Mendeleev's periodic table. And then came the limitations of Mendeleev's periodic table. First one is regarding the position of hydrogen. He could not place hydrogen at the correct position, whether it is a halogen or it is an alkali metal. He could not distinguish this particular point. Second important one is the concept of isotopes was not considered. And the third one is that the atomic mass do not increases in a regular manner in going from one element to the next, because there were gaps in between. So the atomic masses, they did not go in a regular manner. So these were the 3 different limitations of Mendeleev's classification. Apart from these 3, maximum were merits over there. And after this came Moseley with the next law, that is known as the modern periodic law. So modern periodic law, which was stated by Henry Moseley in the year 1913, states that the properties of elements are the periodic functions of their atomic number and not the atomic masses. So this is the new concept that we have introduced. So every element have a mass, it also have a number. Atomic number is the number of electrons which are present, and atomic mass is the number of protons plus neutrons which are present. So Mendeleev suggested that atomic mass was the fundamental characteristic of an element, whereas Moseley suggested that atomic number is the fundamental property of an element. The cause of periodicity is the resemblance in the properties of elements is the repetition of the same valence shell electronic configuration. So if they are having the same valence shell configuration, then they are supposed to have a periodicity in their properties. This was the observation which was made by Moseley through his favorite Moseley curve. So there were some equations and all. Those equations we will be studying in class 11th. Talking about the modern periodic table, that was purely based on Moseley's modern periodic law. So according to that, modern periodic table was formulated, and it consists of 18 vertical columns instead of the 8 vertical columns in Mendeleev's periodic table, and these 18 vertical columns were called as group. There were 7 horizontal rows which were known as periods. The elements belonging to a particular group make a family and usually is named after a first member. For example, group 13 is having the first element boron, so that group is known as boron family. Group 14 first element is carbon, so it is known as carbon family. Group 15 first element is nitrogen, so it is nitrogen family, and so on. in a group, all the elements contains the same number of valence electrons. For example, in the halogen family, if we take the halogen family, the elements are fluorine, chlorine, bromine, iodine, and astatine. So all these elements will be having 7 electrons in their valence shell. Number of valence shell varies from element to element, but the number of valence electrons, that is the electrons which are present in the outermost shell, that is going to remain as the same. Next, in a period, the element contains same number of shells, but as we move from left to right, the number of valence shell electrons increases by 1 unit. When we move from group 1 to group 2, the number of electrons in the valence shell increases by 1. Similarly, from 2 to 3, again a 1. The maximum number of electrons which can be accommodated in a shell is given by the formula 2n square, where n is the number of the given shell. So for the K shell, n is equal to 1. So the total number of electrons which can be accommodated is 2. That is why helium is having maximum of 2, because it have only K shell. If the element is having L shell, then the maximum number of electrons which can be accommodated in the L shell is 8, because 2 into 2 square, that is the formula. 2n square is the formula. For M shell, n is equal to 3, so it is 2 into 3 square is equal to 18. And for N shell, it is 2 into 4 square, that is 32. So these are the number of electrons, maximum number of electrons which can be placed in a particular shell. Now let us talk about the important characteristics of the groups in the modern periodic table. The elements present in a group are separated by definite gaps of atomic numbers. So the elements which are present, they are well separated in definite gaps of 8, 8, 18, 18 and 32. This difference is there in their atomic numbers. That means the first element and the second element is having a difference of 8. Next element is having a difference of 8. Next element will be plus 18. Next will be again plus 18. Next will be plus 32. So if I take an example, I will take group 1, which consists of lithium, sodium, potassium, rubidium and cesium. Let us take this much elements. The first element is having an atomic number 3. We are going to add 8 to that, so that is coming out to be 11. Next we have to again add 8, so it is 19. Next we have to add 18, so it should be 37. Next we have to add again an 18, so it is 55. Next element we have to add 32, so next element is francium, so francium will have 55 plus 32, that is 87. So this is how we are putting the atomic number. First element and the second element is having a difference of 8. Second element and the third element is having a difference of 8. Third and the fourth is having a difference of 18. Fourth and fifth is having a difference of 18. And fifth and sixth is having a difference of 32 in their atomic numbers. So that was the first important characteristic. Next, it has 18 groups in the long form of the periodic table. Elements in a group is having the same valency because they have the same number of valence electrons, and the elements which are present in a group is having identical chemical properties. That is another important point. The physical properties show gradation when we move down the group, but when we are taking the chemical properties, that is identical in a particular group because the chemical properties are determined by valency. Now let us talk about the characteristics of the periods. We know that there are 7 periods in the modern periodic table, and in all the elements present in a period, electrons are filled in the valence shell. As the number of electrons in the valence shell change, there also occurs a change in the periodic chemical properties of the elements present in a period. That means if I take a period, let us take the period 2, which consists of sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. So these are the elements which are coming in group 3. So in period 3. So in period 3 we can see these elements: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, then we have chlorine and then we have argon. So these are the elements which are present. So now if we look at different chemical properties, then we can say that there is a regular gradation of the chemical properties from sodium to argon because they are in different periods. The number of valence electrons changes by 1 unit when we move from sodium to magnesium. Similarly, from magnesium to aluminium again by 1 unit, from aluminium to silicon again by 1 unit, and so on. Since the number of valence electrons are changing, The chemical properties are also not going to be constant, and it is going to be changing in a definite fashion as we move from sodium to argon. Now, the next important thing is the merits of the modern periodic table over Mendeleev's periodic table. First one is regarding the position of isotopes. All the isotopes of the same elements have different atomic mass but the same atomic number. Therefore, they occupy the same position in the modern periodic table, which they should have because all of them are chemically similar. We know that all isotopes are having the same atomic number, so they can be placed together in the same position. That is the first merit of the modern periodic table. Second one is the anomalous pairs of elements. When elements are arranged in the periodic table according to their atomic numbers, then the anomaly regarding certain pairs of elements in the Mendeleev's periodic table, even that will disappear. So that is the second point. Third important point is the explanation for periodicity of properties of elements and their relation with the electronic configurations. Fourth one is that the table is very simple and it is systematic for understanding of the elements and also studying the properties of various elements. So these are the merits of the modern periodic table. Now moving on with the trends in the modern periodic table. This is the second topic in this chapter. First trend that we are going to study is valency. What is valency? Valency is the combining capacity of an atom or a radical, and it is defined as the number of hydrogen, chlorine, and double the number of oxygen atom with which the atom of an element can combine. That is another definition for valency. Valency in a period and valency in a group. This is very, very important. What happens to valency in a period? Period means this. This is known as a period. So the number of valence electron increases from 1 to 8 as we move from left to right. It reaches 8 in group 18, which shows practically no chemical activity under ordinary conditions, and their valency is taken as 0. So that is what is happening. It will go from 1 to 8, again it will start decreasing, and ultimately at group 18 it will become 0. Next is the valency in a group. All elements of a group is having the same number of valence electrons, so they are going to have the same valency. Now talking about the atomic radii. Atomic radii is defined as the distance between the center of the nucleus to the outermost shell of the electrons. Now what is the variation of atomic radii in a period as well as in a group? First let us take a period. In period we can see that the number of electrons are getting increased by 1, right? So when more electrons are added, now the nucleus is going to be much more stricter. Now how is it going to be stricter? It is going to exert more pressure on the electrons which are present on the valence shell, as a result of which it is going to try to keep all the electrons maximum closer to the nucleus. As a result of which, when more electrons are added to the valence shell, then what happens is that the size will decreases as we move along a period. Whereas in the case of a group, the number of valence shells is increasing. When the number of valence shells increases, the nuclear attraction decreases, and as a result of which the size of the atom increases. So along a period, atomic radii will decreases, and along a group, atomic radii will increases. So this is the period wise as well as group wise variation. Next important property is related to the metallic and non-metallic character. Talking about the metallic character, if you are looking at the group 1 and group 2, they are metals. But if you go to the last rows, that is group 17 and group 18, majority of them are non-metals. So what can you conclude? We can conclude that the metallic character decreases as we move along a period. And what happens to the metallic character in a group? When we move from lithium to cesium, the metallic character will increases. That is the important point to note. In a group, it will increases. What is the reason? As we move down, the atomic size increases. Therefore, the distance between valence electrons and nucleus also increases. Thus, the electrostatic force of attraction on valence electrons that will decreases, and hence they can be easily removed. So, if you can easily remove the electron, then it is going to be a stronger metal. But if you can't remove the electron so easily, then it is going to be a weaker metal. So, that is the reason why the metallic character is going to increase down the group, and it is going to decrease down the period. So we can say the opposite for non-metallic character. It is going to decrease down the group and increase along the period. So this was all about the chapter periodic classification of elements, where we discussed about Dobryn's law of triads, Newland's law of octaves, Mendeleev's periodic table, modern periodic table, and some important trends of the periodic table. The first one was atomic radii, second one is valency, and the third one is the metallic and non-metallic character. So this completes our chapter as well as the complete chemistry course. So see you again in the next lecture, where we are going to discuss another chapter from biology, which is genetics, heredity and variation. So thanks for watching, and if you found this video useful, please do like, share and subscribe to the channel. Thank you.